Technology Group today. I've come to meet with Steve Brown, who's going to talk to me about the Hardinge Conquest H51 Super Precision Turning Centre.
MTD CNC, bringing you the latest engineering news, reviews, events and special offers via video media.
Steve, we've looked at many Hardinge lathes before. This one is a little different. This is a Conquest H51. What is different?
This is renowned Hardinge machine, so this is the super precision range. So what we've looked in the past is the GS range, which is our entry-level standard machine. This is really our high-end super precision machine.
Quantify super precision. What can you achieve?
Sub 2 microns. So these machines are really focusing and targeting the grinding market.
These machines, so the H51, is more than that in the range?
Yeah, so 51 denotes to the spindle bore size, so we do a 42mm and a 65mm. Along with the MSY project that's here today has got milling, sub-spindle and Y-axis. Obviously we can go all the way, we can reverse that all the way back to a 2-axis machine.
Now you mentioned they're tackling the sort of grinding market.
Yeah.
Surely you can't turn to similar surface finishes or accuracies that you can with grinding?
Well, certainly can. We've certainly given them a run for the money. So with the likes of our tooling suppliers using CBM, we have very, very high level finishes on here, almost polished finishes.
Really? Okay, that's cracking. Well, what about the actual collet readiness of this machine here then? So there's no chucks, it's all collets?
All collets. So it's renowned Hardinge spindles. The spindle themselves are built and they're actually ground integral to the machine. So the spindle is placed on the machine and it's ground in situ, and that's what gives it its super accuracy.
I didn't realise that. Is that the same on the front and the back spindle?
Yeah, so both spindles are ground integral because obviously the transition between the two spindles, transferring the part, is obviously critical.
And is that the only factor in enabling you to achieve such precision, the spindles, or is there anything else in the build of the machine that we'd need to know about?
The casting is very critical, so it's got a polymer resin built into it, which helps us obviously dampen tool life and rigidity of the machine.
And the turret as well, you're not using a VDI turret here, you're using a BMT turret, is that a factor?
Yeah, so a BMT system, because it's got the driven tooling on, just gives you a higher power, higher torque spindle drive.
And does the control have any influence as well? I mean, you've got a Fanuco eye control here.
Yeah.
Things like processing time, is that important in producing a quality part?
It certainly is. I mean, on this machine, predominantly, it's not about the speed, it's about the accuracy. And it's not to say it's a sluggish machine, but what it just focus on the machine is accuracy. So basically, where a standard part would come off a lathe and have to go onto a grinding machine, this can do it all in one.
And would it be fair for me to say that it's not a machine for everyone, but it's for people that are really looking for, you know, doing high value components? This is the machine.
Yeah, certainly. This machine is normally wrapped up in a turnkey. So what we mean by a turnkey is that basically the customer will just give us a drawing. On that drawing will be a series of features and tolerances that we need to achieve, and we will supply the machine with tooling, with fixturing, work holding and everything.
And it's quite a new machine. Well, I say it's a new machine to the range. It's kind of re-emerged itself. Would that be right?
Yes, so the H series is a stopgap. So obviously we've got the GS, which is entry level, then we have a T series, which is what we class as the world lathe. This machine fits right in the middle of both of those.